day, fellow. Today we are still going to continue with the concept of chemical bonding, but which now the covalent bonding. Let me just say the chemical bond. Don't forget that last time we said the covalent bond takes place between non-metal, two or more non-metals, you see. Then now we are going to say that it is a sharing of electrons between non-metals. See, it's a sharing between non-metals of what? Of electrons. Sharing of electrons between non-metals. Then now, don't forget the concept of valency. Valence electron. That are those electrons in outermost. Electrons in outermost energy level. Outermost energy level. Then the core electrons are the electrons in the innermost energy level. But for the sake of chemical bonding, we are going to consider the valence electrons, the outer one, you see. Then check. Last time I also said to you that all the group 1s will have the valence of 1, 2, will have 2 valence electron, 13 will have 3, then 14 will have 4, then 15 will have 5, group 16 will have 6, 17 will have 7, then group 8, they are most stable, which is 8. And then now let me take hydrogen. Let me take 2 hydrogen. Hydrogen together with another hydrogen. We know that the valence electron of group 1, which is hydrogen in this case, is going to be only 1 plus another 1. Then we write 1. Bear this in mind, we have a non-metal and non-metal. You see, for this one, they share what? They are going to share electrons like this. I'm going to have this one. Then, see, the valence electrons of this and this, they will share the electron. You see, whenever we have 2 electrons which are sharing, we say such a bond is a single bond. We have a single bond. For 2 electrons, we get what? A single bond. See, let us consider oxygen now. If we take oxygen, we know that oxygen is situated in group 16 is going to be, say, 1, 2, 3, 4, 5, 6. Then let me take another one. It's going to be the same. See? Then, how then are we going to write the Lewis diagram for the 2 combined? Then it's so simple. Check. We have unpaired electron, this one together with this one. On this side, we have this one together with this one. That means this will pair with this, therefore this will pair with this. Eventually we are going to get a situation which is now like this. Let me write this 2 here. Then they will pair with what? With these 2. They will come together and pair with this one. You see, they will pair together like this. Now at the end of the day, we must satisfy the octet rule, which states that the valence electrons of each at the end of the day, they should be 8. You see, as we can see that we have 1, 2, 3, 4, 5, 6. Let us include this one, 6, 7, 8 for the first one. If I consider the second one, I'm going to have 6 together with this one. It satisfies what? The octet rule. All the group 7, 6, 8 is already stable. They should satisfy what? An octet rule. In the outermost energy level at the end of the day, I should have how many electrons? 8 for each. Like this oxygen, it will have 8, including the 2 from the other one. You see? Then now, I have 4 electrons which are sharing now. Here I only had 2, now I have 4. Then for 4 electrons, we get a double bond. We get a double bond. You see? And now let us consider nitrogen. Nitrogen is situated in group number 15. You see? Here's nitrogen 15, you see? Then it's going to have 5. The outermost. Going to be 1, 2, 3, 4, 5. Then let me take another one. Plus another one. Going to be like this. How many unpaired? 1, 2, 3. Then they will eventually share. You see? Which now is going to look like this. Let me put these 2 here. Then these 3, 1, 2, 3, they will pair with this one, 1, 2, 3. Then at the end of the day, they must satisfy what? An octet rule. Check. If I decide to hide this one, you see, let us count the entire 6 already, 7, 8. You see, I have 8 electrons. Same applies if I hide this one. I have how many? Sorry. If I hide this one, I'm going to have 6 plus 2, which is 8. It satisfies what? An octet rule. Now we have 6 electrons. For 6 electrons, we get a triple bond. We have 6 electrons which are sharing. Or let me say 3 from 3. In total, there are 6 electrons. Then we are going to get a triple bond. Then now, let's say if I decide to give you something which is like this now. Let's say if now I decide to give you let's say I ask you to draw a Lewis diagram of carbon dioxide. How are you going to draw the Lewis diagram for this one? Check, it's so simple. We have only one carbon. 1, 2, 3, 4. Plus 2 of what? of oxygen. 1, 2, 3, 4. It is situated in group number 16. Then carbon, it is situated in group number, let's see, 14. You see, it will have 4 valence electron. Then I also have like this. Then how are we then going to to write the Lewis dot diagram for the combined CO2? Check, it's so simple. I want to alert you of something. The group 1 elements, they can only, sorry, I wanted to say group 17, then group 16, group, let me write group 15 together with group 14. You see, then group 17, they can only form one bond, don't forget that. Then group 16, they can only form 2 bonds, this one 3, this one 4 bonds. You see, they can only form 4 bonds. Check. I have carbon dioxide. Carbon dioxide is situated in group number 14. Group number 14 is going to have 4 bonds. You see, then oxygen, it is situated in group number 16. It's going to have 2 bonds. How? Then the one with most bond is going to be situated in the middle. Then okay, let me write here. I don't have much space here. Then it's going to be C. Then let me put 2 of each like this. You see, then it has to satisfy what? An octet rule. You see, it has to satisfy an octet rule. I have 2 unpaired, you see, electron. Then they will come and join up with this one. Then I'm going to have something like this. Same applies. These unpaired electrons, they will join up with this carbon over here. At the end of the day, I'm going to have something like this. Check. Carbon, if I consider carbon in the middle, let us count the number of electrons. We have 1, 2, 3, 4, 5, 6, 7, 8. You see, it satisfies what? An octet rule. Same applies. If I then now move to what? To oxygen and try to hide out this one, I'm going to have 2, 4, 6, 8. It satisfies an octet rule. Same applies to this one as well. 4 already, 6, 8. It also satisfies an octet rule. You see, if I were to represent like the paired dot with a line, it would have been like this. Let's say if I replace this bond with the line, I replace another one with the line, then I replace this one with the line as well, like this. You see, I wanted you to see that at the end of the day, carbon in group number 14 is going to have how many bonds? 1, 2, 3, 4. You see, then this oxygen, it is situated in group number 16. It's going to have how many bonds? 1, 2. Same applies to this one. Only have 2 what? Bonds. See, I wanted to highlight that. And again, there is another thing that I wanted to stress out, which now is NH3. Let us consider now NH3. You see, we have one nitrogen. It is situated in group number 15. It's going to have 5. 1, 2, 3, 4, 5. Then how many hydrogen do we have? 3. We have 1, 2, 3. Then the final diagram will look like this. You see, we have 3 unpaired. You see, if we go back to the number of bonds, nitrogen, it is situated in group number. This one, it represents the number of bonds. Here we have the number of bonds. Nitrogen, it is situated in group number 15. It's going to have 3 bonds. You see? Check. Each hydrogen will go and pair out with this one. This one will go pair out with this one. Same as this will go pair out this one. Like this one will move here. This one will go there. Then that last one will go over there. At the end of the day, I'm going to have something which is like this now. H C, something which is like this. You see, if I decide to replace this with what? With a line. With a line. At the end of the day, I'm going to have something like this. You see, how many bonds do nitrogen have? 1, 2, 3. You see, it has 3 bonds. You see, I wanted to highlight that at the end of the day, the nitrogen will have 3 bonds. Then another thing is that hydrogen it is situated in group number 1, will always have 1 bond. See, each hydrogen has 1 bond, but for nitrogen we have 1, 2, 3 bonds surrounding what? The nitrogen. See, now lastly, I want to highlight something. Okay, let me just leave out this one. Then if I take these 2 hydrogen, I'm going to have a line which is like this to represent the bond between these 2 hydrogen. Check this now. If we have the same element sharing what? Electrons, we get a non-polar covalent bond. Covalent bond. You see, if we get a bond between 2 of the same, it's a non-polar covalent. Then between the 2 elements which are not the same, we get what? A polar covalent bond. You see, this one non-polar covalent bond, this one is going to be polar covalent bond. But you are going to do these ones in depth when you reach grade 11. For now, we can just stop here. For non-polar of the same, for polar of different elements. You see, I'll just stop here for you. Great, thanks. Now, my fellow learners, I thank you and enjoy.